So the second kind of application problems here are geometry problems, and the geometry problems are all going to be about the area of a rectangle. And so there's a few things that kind of come along with this. Mostly I like drawing pictures for these, and I like labeling the information on there to develop my equation. The other thing that's part of the equation is that area is always equal to length times width. And so that bit of information is key as we move forward in these geometry problems. So the first one right off the bat here says that the area of a rectangular sheet of paper is this. We know the area. We're also given some information about the dimensions of this piece of paper. It says that the length is 5 centimeters more than the width. So we're supposed to figure out the dimensions of this rectangle, both the length and the width. I like drawing a picture of these to get started. The other thing that is what you're comparing to gets to be x. So the width is going to be x, and the length I'm going to have to translate. It says the length is 5 centimeters more than the width. So whatever the width is, the length is 5 centimeters more. So I've drawn a picture and I've labeled the sketch of the problem. Once the sketch is labeled, I now have this framework equation that I can put all the information together with. So the area from the question says it's 300 centimeters squared. And I now have these two expressions that represent the dimensions of my rectangle. Now, it doesn't matter whether you multiply the width times the length or the length times the width. I wrote them this way because that's the way we're used to seeing things in algebra so far in this course. Now, this is not quite yet a quadratic equation. We still have a little bit more work to do in making this look like a quadratic equation. We're going to have to set it equal to 0. So here now I have something that has A, B, and C values in it. This gives me the raw material to sub into my quadratic equation. So that would be negative B plus or minus the square root of B squared minus 4AC all over 2A. So a little work on my calculator. I always like filling out what I can really easily. That stuff on my calculator there, if I sleuth a little bit harder, I'd get that it's, what is it, 1225. And I would take and hit the square root button on there because that gives me a nice even number. So one of those projectile ones wasn't a nice even number. This one is absolutely fine. I'd get negative 5 plus that square root, which is 35, divided by 2, and I'd get the negative option because remember we've got the two options in there. So negative 5 minus 35 divided by 2. This one's going to give me a negative number. That's going to give me negative 20. Sorry, negative 20. We're going to reject that one because that doesn't make any sense in the world of geometry. And this one we're going to hone in on a little bit. So that'd be 30 divided by 2, x would equal 15. Now this gives me a little bit more information. So let's keep going on the steps here. I get ahead of myself. We check to both see if both solutions make sense. We're going to reject the negative solution because length can't be a negative. So now we only entertain the positive option. We're going to plug these x values back into the diagram expressions. Remember I said that width was x and length was x plus 5. So I now know what x is equal to. Now I need to answer my question. So I know that width is going to be 15 centimeters and the length is going to be 15 plus 5 or 20 centimeters. The last part of this is to answer the question. So the answer to this is that the rectangle dimensions would be 15 centimeters by 20 centimeters. You'll notice that all of these questions are much the same. We have 2 more to do in this geometry set. The next question is about, again, a rectangle. This time the length is 2 more than 3 times its width, and we know that the area of it is 33 inches squared. So I'm going to start by drawing a diagram. I know that my width is going to be x, and then I have to do this translating business here, right? 2 more than 3 times the width. So if width is x, we'd have 2 more than 3 times the width. We've done things like this, but now embedded in a word problem. Sometimes that is a bit of a tricky part of these geometry problems. We know that we have the framework that area equals length times width, right? And we know our area. So we've got 33 equaling x times, 3x plus 2. We need to make this look, like we're used to seeing it so that we can plug it into the quadratic equation. I'm going to subtract 33 from both sides. And what I get is that 0 equals 3x squared plus 2x minus 33. This gives me the a, b, and c values to plug into the quadratic equation. So x would equal negative 2 plus or minus the square root of 2 squared minus 4 times 3 times negative 33 all over 2 times 3. Clean this up a little bit. On my calculator, I figured out this was equal to the square root of 400, which is awesome because that's a nice neat number. I have my positive option, and I have my negative option. If I do the math on this, I get two options here. So I'd get 18 divided by 6, or x equaling 3, or negative 22 divided by 6, which is ugly. It's a negative number. So we're going to reject that one because in the world of geometry, that doesn't make any sense. So now that we've got this, it's not quite our answer. We need to take that back to our diagram. We know that the width was x and the length was this 3x plus 2. So now that we know what x is, we know that the width is 3 inches and the length would be 3 times 3 plus 2. That would be 9 plus 2. That would be 11 inches. And the final answer is that the rectangle is 3 inches by 11 inches. One last one to do. This time, again, a rectangle. So I'm going to draw the picture. Now it says that the length is 4 centimeters less than the width. So this is going to be x. Oh, less than twice its width. So this will be 2x minus 4. Again, we're given an area because we know that area equals length times width. That's my framework equation. So 240 would equal x times 2x minus 4. We need to make this look in quadratic form. So I'd have 240 equaling 2x squared minus 4x. Subtract 240 from both sides to set it equal to 0, and we can clearly then see our a, b, and c values. And now we have the raw material to sub into my quadratic equation. So this would be negative b plus or minus the square root of b squared minus 4ac all over 2a. Make this look a little bit neater. Everything under the radical there amounts to 1936. And when I got that in my calculator, I hit the square root button, which worked out nice and neat and easy. I'd have the positive option being 4 plus 44 over 4, and I'd have the negative option, so x equaling 4 minus 44 over 4. This one's going to end up being a negative option, so that'd be a negative 10. So I can reject it, whereas this one ends up being 48 over 4, or x equaling 12. I can now take that back to my equation. So the width and the length. The width was x, so that's 12. And the length is 2x minus 4. So I take 2 times 12 minus 4. That's 24 minus 4, or 20. And so the rectangle is 12 centimeters by 20 centimeters. You could always take these back and multiply them. Do they give you the area? So those are three, like the rectangle, geometry problems that you are going to see in your homework and on in the course. So yeah, I think the key to those is that translating to come up with the expressions for the length.